Consciousness is one of those words we use constantly and almost never agree on. We speak of it as if everyone knows what it means, yet the moment we try to define it, it begins to dissolve. Is consciousness awareness? Is it intelligence? Is it the ability to think, to feel, to remember, to suffer, to observe? Or is it something quieter, the simple fact that there is something it feels like to exist at all? Before we can even ask whether the universe could be conscious, we have to slow down and ask a more uncomfortable question. What exactly are we talking about when we say consciousness? In everyday language, consciousness is often confused with intelligence. We call humans conscious because we solve problems, build tools, write poetry, and ask questions about the universe. We hesitate to call animals conscious if they cannot do these things in ways we recognize, and we almost never apply the word to systems that do not think in sentences. But intelligence and consciousness are not the same thing. A calculator can outperform a human at arithmetic without experiencing anything. A large language model can generate fluent text without feeling a single emotion. Intelligence can exist without awareness. Consciousness, at its core, seems to be something else entirely. Most neuroscientists today define consciousness not as thinking, but as experience. The redness of red, the pain of pain, the sensation of time passing. Consciousness is not what you do, it is what happens to you while you are doing it. This distinction matters because it immediately complicates the idea that consciousness must look human to exist at all. Experience does not announce itself. It does not require language. It does not require logic. It simply requires that information is being processed in a way that generates a point of view, however faint or unfamiliar that point of view might be. But even this definition is slippery. Where exactly does experience begin? Does a sleeping person lose consciousness entirely, or does it fade into a quieter form? Is a dreamless coma a complete absence of experience, or merely an experience we cannot remember? And what about animals, insects, single-celled organisms? At what point along the ladder of complexity does the lights-on moment occur? Science has no clear answer, because consciousness does not leave behind physical fingerprints in the way bones or atoms do. We infer it indirectly from behavior, from neural activity, from self-report. Consciousness is private by nature. We only ever know it from the inside. This is why consciousness has resisted clean scientific definition for centuries. Physics can describe how particles move. Biology can describe how cells function. Neuroscience can map correlations between brain activity and reported experience. But none of these explanations tell us why any of it feels like something from the inside. This gap is known as the hard problem of consciousness. The problem of explaining how subjective experience arises from objective matter. It is not a small gap, it is a canyon, and every serious theory of consciousness must eventually confront it. Because of this difficulty, many thinkers quietly shift definitions without noticing. They begin talking about consciousness as if it were simply complex computation. Information goes in, information comes out, therefore consciousness is present. But computation alone does not guarantee experience. A thermostat responds to temperature. A traffic system responds to congestion. A galaxy responds to gravity. Responsiveness is not the same as awareness. If we define consciousness too broadly, it becomes meaningless. If we define it too narrowly, we risk mistaking our own reflection for the entire phenomenon. This confusion is especially dangerous when we scale the question up to the universe itself. If we casually define consciousness as complex behavior, then the universe is obviously conscious. It evolves, organizes, responds, adapts. But if we define consciousness as human-like thought, then the universe is obviously not conscious. It does not speak, plan, or desire in ways we recognize. Both conclusions are shallow because both rest on definitions that were never examined. The real work begins in between these extremes. To make progress, we have to separate three ideas that are often blended together: consciousness, intelligence, and self-awareness. Consciousness is experience. Intelligence is problem-solving. Self-awareness is the ability to represent oneself as an object in the world. Humans have all three, but there is no rule that says they must always travel together. Many animals appear conscious without being self-aware in the human sense. Some artificial systems are intelligent without being conscious at all. Once we untangle these concepts, the space of possibilities widens dramatically. Consider this. A newborn infant is conscious but not self-aware. It experiences sensations, emotions, and discomfort, yet has no concept of itself as a separate entity. Self-awareness emerges later. If consciousness can exist without self-awareness in humans, why should we assume that self-awareness is required for consciousness at any scale? This assumption alone has quietly shaped how we think about the universe. We expect consciousness to announce itself with an ego, a voice, a center, but that expectation may say more about us than about consciousness itself. Another hidden assumption is that consciousness must be localized. We imagine it sitting somewhere specific, in the brain, behind the eyes, inside the skull. Neuroscience encourages this view because damage to certain brain regions alters experience, but correlation is not identity. The brain may not contain consciousness so much as enable it, the way a radio enables music without producing the broadcast itself. This metaphor is imperfect, but it highlights an important possibility. Consciousness might be a process distributed across systems, not a thing trapped inside an object. When we examine consciousness scientifically, we notice something strange. It does not appear as a single unified phenomenon. It fragments. Split-brain patients can show two streams of awareness within one skull. Under anesthesia, consciousness does not switch off cleanly. It degrades. Psychedelic states dissolve the sense of self while preserving vivid experience. Meditation can quiet thought while awareness remains. These observations suggest that consciousness is not an all-or-nothing property. It exists in degrees, modes, and configurations. If consciousness comes in degrees, then asking whether the universe is conscious becomes less absurd and more nuanced. The question shifts from, is the universe conscious like a human, to, does the universe participate in processes that resemble the foundations of experience? That shift alone transforms the problem. Instead of hunting for a cosmic brain or a universal ego, we begin examining patterns, integration, feedback, memory, responsiveness, and information flow. Definitions matter because they set boundaries on imagination. For centuries, life itself was narrowly defined. Anything without motion, breath, or reproduction was dismissed as dead. Then we discovered viruses, then extremophiles, then self-organizing chemistry. Life turned out to be less of a category and more of a spectrum. Consciousness may be undergoing a similar redefinition. What once seemed mystical is gradually being reframed as a natural phenomenon. Not trivial, not solved, but not supernatural either. This reframing does not reduce consciousness, it expands it. If consciousness is not a magical spark added to matter, but an emergent property of certain kinds of organization, then it becomes something the universe can do, not just something it can contain. This idea is unsettling because it erases a comfortable boundary. We like to believe consciousness is rare, fragile, and special, a flame flickering briefly inside a vast, indifferent cosmos. But what if consciousness is not an exception? What if it is a tendency? At this stage, skepticism is healthy. Many claims about cosmic consciousness collapse into vague metaphors or disguised spirituality. That is not what this exploration is about. The question is not whether the universe has intentions, desires, or beliefs. The question is whether our current definitions of consciousness are too narrow to capture its possible forms. The universe may not think, but thinking may not be the essence of consciousness to begin with. When we strip away mythology, ego, and human bias, consciousness begins to look less like a spotlight and more like a field, less like a voice and more like a sensitivity, less like a command center and more like a pattern of responsiveness unfolding over time. This does not prove that the universe is conscious. It does something more important. It reveals how little we actually understand the thing we claim ownership over. When we imagine consciousness, we almost always imagine a brain. Neurons firing, electrical signals passing through dense biological circuitry, a centralized control room where experience somehow gathers and becomes real. This image is so deeply ingrained that it feels almost obvious, as if consciousness and brains were inseparable concepts. But this assumption is not a discovery, it is a habit, and like many habits, it begins to break down the moment we look too closely. Life existed on Earth for billions of years before brains appeared. For most of the planet's history, there were no thoughts, no language, no memory in the way we understand it, and yet life persisted. It adapted, it responded, it survived catastrophes, radiation, freezing, boiling, chemical chaos. If consciousness were strictly dependent on brains, then nearly all of life's history would have unfolded in total inner darkness. That possibility is not impossible, but it is far from obvious. The deeper question is whether experience truly requires a nervous system, or whether nervous systems are simply one way of organizing something more fundamental. Single-celled organisms offer the first crack in the brain-centered view of consciousness. A bacterium has no neurons, no synapses, no centralized processor, and yet it behaves in ways that are difficult to describe as purely mechanical. It moves toward nutrients, it retreats from toxins, it remembers past conditions and adjusts future behavior accordingly. Some bacteria can even communicate chemically with one another, coordinating actions as a group. This is not intelligence in the human sense, but it is responsiveness with memory. It is decision-making without deliberation. It is life acting as if it knows something about its environment. The unsettling part is not that cells behave intelligently, it is that they do so without anything resembling a mind. Inside a single cell, countless molecular processes unfold simultaneously. Signals are detected, amplified, suppressed, stored. Feedback loops adjust internal states in response to external conditions. If we strip away our attachment to neurons, what we see is a system processing information in real time. The cell does not think, but it does sense, and sensing is the raw material of experience. This leads to an uncomfortable question. If a system can sense, respond, and adapt, at what point does experience begin? Does a single cell feel something when it detects sugar? Or is that language a metaphor stretched too far? Science cannot answer this directly because experience does not leave a measurable trace, but the absence of evidence is not evidence of absence. All we can say with confidence is that the boundary between mere chemistry and something it is like to be is far less clear than we once assumed. As life becomes more complex, consciousness does not suddenly switch on. It accumulates. Consider simple multicellular organisms, jellyfish, sponges, worms. Many have no centralized brain. Some have nerve nets rather than command centers. Information flows across their bodies in distributed patterns. There is no single place where the experience lives, and yet these organisms interact with the world in coordinated, purposeful ways. Pain-like responses appear. Learning-like behaviors emerge. If consciousness exists here, it is not localized, it is spread out. Now scale up further, not to bigger brains, but to collectives. Swarms of insects provide one of the clearest examples of intelligence without a central controller. An ant colony can solve problems that no individual ant understands. It can find the shortest path to food, allocate labor efficiently, regulate temperature, and respond to threats. No ant has a map of the colony. No ant knows the plan. Intelligence emerges from interactions, not instructions. From the outside, a swarm behaves like a single organism. From the inside, it is a network of simple agents following local rules. This gap between local simplicity and global complexity is one of the most important ideas in modern science. It appears everywhere, in brains, in ecosystems, in economies, in weather patterns. Consciousness, whatever it is, may be another instance of this pattern, rather than an exception to it. Ecosystems push this idea even further. A forest has no brain, no awareness center, and yet forests regulate themselves. Trees communicate chemically through root networks. Fungi distribute nutrients across vast underground systems. Populations rise and fall in response to feedback loops that maintain balance until disrupted. When viewed as a whole, an ecosystem behaves like a coherent entity, responding to stress, adapting over time, and sometimes even collapsing when thresholds are crossed. Is an ecosystem conscious? Almost certainly not in any human sense.